Hi everyone, and welcome back to another episode of Dr. Carl Explains, your YouTube channel where we go through GCSE science content quickly and easily. Today we're going to be going through exothermic and endothermic reaction profiles. Now these often seem quite complicated, but they are honestly really easy to get full marks on once you know what you're doing. So without further ado, let's grab a pen, grab some paper, and let's go ahead and jump in as soon as you've hit that like button. Cool, let's get going. Okay, so key information then. So exothermic reactions release energy to the surroundings. Now this is often a two-marker question, so you need to have the exothermic reactions release energy and to the surroundings, and then conversely endothermic reactions take in energy from the surroundings. Don't forget that last bit of to the surroundings or from the surroundings. Now just to give you some examples, exothermic reactions often used for things like hand warmers. Endothermic reactions, kind of like cold sports injury packs. But any kind of example that you may know that would be for an exothermic or an endothermic reaction would be perfectly acceptable. But the example would have specifically specified hand warmers and cold sports injury packs as examples they want you to know. Okay then, so activation energy. Now this is a really important concept to understand. Please do make sure we know this definition, and that is the minimum amount of energy needed to start a reaction. So just to really quickly explain that, if we have, I don't know, random chemical A and random chemical B, they first of all need to collide with each other, need to touch each other. And then not only do they need to kind of bump into each other, they have to have the right amount of energy. And that's often why we heat reactions up to then get them to work. It's a little bit like putting a pizza in the oven. You could put it in 180, 200, it will cook. But if you leave a pizza in a fridge at 10 degrees, it's not going to cook. The cheese is never going to melt because there's not enough energy to get that pizza, that reaction to get started. So there's always got to be that minimum temperature, that minimum amount of energy in a reaction to start the reaction. Now, some reactions could be very, very cold. Obviously, it depends, but there's always that minimum amount of energy to get it started. Okay then, so reaction profiles / energy level diagrams. There are two types you need to learn, one for exothermic and one for endothermic. So first of all, if we just kind of draw out our, axes here, and then at the side here would be energy, and then down the bottom here is often kind of like progress of reaction. Now this is essentially time. Okay, so it's basically how long it's taking the reaction to start. So you would start with your reactants, which would go here. And then we're going to do an exothermic reaction. So our products are going to be lower in energy once they've finished. So I'm just going to write R for reactants here and P for products down here. Now it is important to know all of these labels for your GCSE. And then nice and simply, all you do is you just show kind of the energy moving from one side to the other. So you just kind of arch it over like that. Now, from the very top of this to the reactants, that's there. This is called your activation energy. And then from the bottom of that arrow down to there, that's the product line. That is called your energy change or your energy difference. Now, hopefully what we can see, now this is an exothermic reaction, and hopefully what we can see, exothermic reaction just there, is imagine, say, and you wouldn't have to draw this bit for your exam now, let's say you've got kind of like a man with a boulder, got to push his boulder up over there, he's going to push his rock over the hill like that. Now, obviously that activation energy, that minimum amount of energy to start that reaction, he has got to push that rock all the way up to this point here. That's the minimum amount he can do it. He could do it further and that would get it over the hill. But if he doesn't push it far enough, say he only gets to this point here, that's not enough energy to get it to roll over here. So he's got to push it up to that point up here, that activation energy, the minimum amount of energy to get that boulder to roll all the way down to the product side. Now, once he does that, once the ball starts rolling, once it gets to the level here, which would be kind of halfway, as you can see just there on the other side, hopefully we can see there is the same amount of energy on this side and the same amount of energy on this side of the reaction. And so because the products are lower in energy, once that boulder falls all the way over to the other side here, hopefully we can see from here to here, which is our energy change, that's how much energy is then given out. And because it's an exothermic reaction, the products are lower in energy, and so energy is given out to the surroundings. Now, obviously, you do not have to draw a man with a boulder in your exam, but hopefully that just kind of explains all of those kind of definitions and why the products are lower in energy than reactions. If you're still a little bit unsure, have a look at the endothermic reaction now. Okay, so again, we're going to draw endothermic. We're going to draw our reaction profile just in here like so. And exactly the same, energy on the side, that's how much energy is going in. And then you've got a progress of reaction at the bottom, which is essentially just time. Progress of reaction at the bottom. You would start here. Again, your reactants. Remember, your reactants always start on the left-hand side of a reaction. But the difference this time, your products are going to end up higher in energy. And so I'm just going to write R for there and P for there. Again, we show the flow of energy going over, just like so. And then we always start with our reactants, top of the hill, go down to there, to there. So remember, you've got to put that energy in first. So this line there is your activation energy. Activation energy. And now your energy difference or your energy change is from here to here. So that's your energy change just here. Now you do need to learn how to label these and learn how to draw these. Now this, as I said, this is for an endothermic reaction. Now that's going to be your perfect answer for how to draw a reaction profile or an energy level diagram for an endothermic reaction. But again, if we just draw our man with our boulder again here, again, activation energy, he's got to push it all the way up to the top here. And hopefully this time you can see that once that boulder gets to the top and it rolls back down to the other side, it doesn't get the same amount of energy out. So there to there, this is not equal from there to there, this side of the kind of the half of the graph, as it were. So can we see there is more energy on this side? More energy has gone into the reaction than is being given out of the reaction when it comes down. And so therefore the energy change is going to be a positive energy change. The energy change is going to be taken in from the surroundings. It's not going to be lost to the surroundings. Hence why the products are higher in energy. Okay, so if you do need any more help with your GCSE Science, please do check out more of my videos. Thank you very much for watching. And if you ever need help with your GCSE Science, Dr. Kyle explains.